lesson 5-7, roots and zeros. So by the time we're done with this lesson, we should be able to determine the number and type of roots for a polynomial and find the zeros of a polynomial. So to start with, we have the fundamental theorem of algebra. So this says a polynomial equation of degree n has exactly n roots in the set of complex numbers, including repeated roots. Roots can be real, rational, irrational, imaginary, or any combination. So essentially what this theorem tells us is that when we are solving polynomial equations, we're going to have the same number of answers as the highest power. And then for the second part, we have a couple of theorems to go along with that. So this repeated roots is talking about the multiplicity. So this is the vocabulary term we use to describe a root that repeats. And it's just the number of times that it repeats. And then for the irrational and imaginary root theorem, this tells us that if we have one of those, then we also have its conjugate. So if a plus bi is a root, we can also assume that its conjugate, a minus bi, is a root. Okay? Same thing, if I have a plus bi, then we're assuming that its conjugate is also a root. Okay? So we're just going to do some solving examples to demonstrate this information. So again, we want to use the methods that we've learned up to this point. So we're looking at factoring right now. So on problem 1, we can use greatest common factor to start. So we would factor out an x, and we would have x squared plus 9 left equal to 0. And then we can't factor that anymore, so we're just setting each group equal to 0. And then we are getting the x by itself. So this one, there's nothing left to solve. So one of our answers is just going to be x equals 0. And then on this one, we are going to subtract the 9 over and then take the square root of each side. So the square root of 9 is 3. And then because it's negative, we're going to have an I. And since we're taking a square root of something, we need to remember that we have a positive and a negative answer. Okay? So again, this is showing that if I have one imaginary root, that we have its opposite. So we have both the positive and the negative I here. So that's using these irrational and imaginary root theorems. All right, next one, again, if we solve this, so this is factorable. So we're looking for two numbers that multiply to be 9, add to be 6. So we will have x plus 3 and x plus 3. Again, we're just setting each group equal to 0. And then solving. So we would subtract the 3 over. And then that one we are also subtracting the 3 over. So again, we have two answers, and our highest power is a 2. And because they're repeating, we can say that x equals negative 3. And then behind it, we can put multiplicity. And then it's showing up twice, so it has a multiplicity of 2. So again, even on this one, we have 3 answers, which was our highest power, because our plus minus represents 2 different answers. And the third problem, so if we solve that one, we can also do that by factoring, and it'd be factoring by grouping. So if we group the first 2 and the last 2, from the first 2 we can factor out an x squared, and then we would have 3x minus 1 left. From our second group we can factor out a positive 3, and then we would have 3x minus 1 left. So now I'm going to factor out that entire group, so 3x minus 1, and then x squared plus 3. And we can't factor our squared term any further, so now we're ready just to set each group equal to 0. So 3x minus 1 equals 0, and x squared plus 3 equals 0. So when we're done, we should expect to have 3 answers. So this one we're going to add the 1, and then divide by 3. So 1/3 is our first answer. Here we're going to subtract. So x squared equals negative 3, and then take the square root of each side. So again, because we're taking a square root, we're going to have a positive and a negative. Since we have a negative in the radical, we have an I, and then we can't simplify the square root of 3, so that's just going to be our answer. So these are the final 3 answers. So again, 1/3 is 1 answer, and then the plus minus represents 2 answers. And again, we're demonstrating the imaginary and irrational root theorems because we have both a positive radical and a negative radical. So those always come in pairs, so one positive, one negative.